All right, so now let's run it back and let's do the second part, which is to determine whether the relation is a function. Okay, so a relation is a function, remember, when there's one unique output for each input. Okay, so one unique output for each input. So in other words, if I say for something to have functionality, like a calculator has functionality, right? If you put in 2 plus 3, you always get 5, right? If there was a device where you put in 2 plus 3 one time and you got out 5, and another time you got out 6, that would not be functionality, right? Another example that I usually use is like a toaster, right? If you put in bread and you push the button, you're gonna get out toast, right? If one time you put in bread and you got out toast, and another time you put in bread and you got out a banana, that would be kind of cool, but it wouldn't be a function. It wouldn't be a function, right? It would be a cool mystery machine. It would be a cool relation, but it wouldn't be a function. A function is if you have a given input, you know what you're going to get out of it, or maybe even if you don't know, there's one thing you get out of it, right? There's one single value that's produced by each particular input. Okay. Now, one to one is where every single input or every single output has one unique input. Okay. So one to one goes both ways. So there's one output for every input, and there's one input for every output. Okay. So that's what a one to one is. And I remember I have the definitions before, so you can check them out. Now, onto function is actually something I haven't heard of until this textbook, we adopted this textbook and I was checking it out. But an onto function is where each value in the range is associated with one value in the domain. So, all right, and then functions could be both or neither, right? So I think mapping diagrams are the easiest to tell, in my opinion. But like for example, let's just take a look at this one here. So this is a function because there's one arrow coming from each input, right? Remember, there's one unique output for each input. So if there's just one arrow coming from it, then it's a function. So this would be yes, or you could just put let's just put function, and you can abbreviate FN for function. Okay, so that is a function, right? And is it one to one? So one to one means that there's one arrow coming from each of the inputs, and there's also only one arrow going to each output. So this right here, this situation right here makes it not one to one. So it's not one to one. Okay, so let me just go down the list. It's not one to one. Is it onto? Onto would be if each of these has one corresponding input, right? So this would be onto. So let me add that to the list, onto, because each of these corresponds with the element. What's not onto is if you had like an extra value, like let's say you had 500 here and nothing was associated with it. So if it was in the range but not associated with an element in the domain, that would not be onto. Okay. All right. And so obviously it's not both or neither because it's one of them and not the other. So, okay. So that's basically how it works. Now, for it not to be a function, that's when you have two elements or two arrows coming from one input, right? So this would not be a function. All right, because we have a value there. Okay, or we have a value 8 that has two outputs, right? It outputs the 50 and it outputs the 60 at the same time. So I don't know if someone gets 8 absences, I don't know if they're gonna get a 50 or a 60, right? It's a relation, but it's not a function. All right, now let's go back to the ordered pairs and see what it looks like for it to be a function or not. So for it to be a function, you shouldn't have any repeats in the domain, right? Because if you have repeats, that means there's two outputs for that one input, right? So this one would be a function, right? And we saw it on the mapping diagram, the same one, right? But that's what a function looks like, okay? Now it's not one to one because of this, right? Because the domain, so for it to be one to one, the domain and the range have to have no repeats, okay? No repeats in the domain and range for it to be one to one. But it is onto because we don't have any kind of empty outputs, right? For a set of ordered pairs, really you don't ever see onto. Onto is kind of something, once again, I haven't seen before. I don't think it's too common of a thing, so I wouldn't worry about it too much. But anyway, just wanted to be consistent with the text. So here's an example of something that's not a function because the domain repeats, right? So when you see that repeating domain, it's not a function. So it's okay. It can be a function if the range repeats, but not if the domain repeats, okay? And then lastly, for a table, you can see here, none of these repeat. So that means it is a function, right? And then you check here, do any of these repeat? And the answer is no. So that means it's one-to-one, right? And then is it onto? Yeah, each of these has an element in the domain it's associated to, right? So it is also onto. So this is actually both, right? So it's a function and it's both. And this is what it looks like in a mapping diagram, right? One arrow coming from each input and one arrow going to each output, right? All right, so that's how you determine if it's a function or not with mapping diagrams, tables, and ordered pairs. With the graph, it's actually maybe a little bit easier because you can do what's called the vertical line test, okay? Vertical line test. All right, and we'll just call it the VLT for short. All right, so vertical line test says, remember, for it to be a function, it has to pass, or it has to have one output for each input. So in other words, like if I have a point somewhere, it corresponds with the X value. It can only correspond with one Y value. So if I have another point that is stacked like this, then this one X value, this one input at 1 has two outputs, right? It has an output at 2 and it has an output at 4. So this is how you tell if you have 2 points that are vertically stacked, then you have 2 outputs or more than one output for that one input, right? So that's why you do the vertical line test. You just basically visualize, if you draw a vertical line anywhere, is there any line that's going to cross through more than one point? And when you find that value, that means it's not a function, okay? All right, so like this one does pass the vertical line test, right? There's no point, there's no vertical line that's going to go through more than one point anywhere along here, right? So I can scan all along. I kind of do like a kind of a barcode. That's kind of the way I think of it, is you kind of, you know, beep 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 beep, and if you get one barcode or one line that crosses through 2, then the alarms go off, sprinklers come on, everything, and it's not a function, okay? So this one is, because there are no vertical lines I could draw through any point that would cross through more than one point on the graph, okay? Same thing here, right? This one passes the vertical line test. So think about if you scan those vertical lines all the way across, there'd be no point where it crosses twice. Now here, on the other hand, we have a lot of issues, right? Here that actually crosses 1, 2, 3, 4 times, right? So this one would definitely not be a function. Okay, so this one is, and this one's not, okay? So of these two, here's a little tricky thing. If you have an open circle over a closed circle, that's actually okay, right? Because if I draw a line through there, the function exists at this point, but it does not exist at this point, right? It exists on an open circle, but doesn't exist on the closed circle. So this would actually be a function. Okay, so it's okay to have an open circle stacked with a closed circle. What's not okay is to have 2 closed circles stacked, right? That would not be a function. All right.